Good morning, Chem 20s. Our lesson today is another review lesson, this time on the periodic table. The periodic table can be arranged into periods and groups. Periods are the horizontal rows that go across your table. As you can see from the diagram, there are 7 periods on the periodic table. The easy way to know which ones are the periods and which ones are the groups is to remember this. At school, you have a small number of periods. In a normal year, you would have 5. On the periodic table, you have a small number of periods. On the periodic table, there are 7. You will see that there's a repeat 6, 7, because if you check the atomic number, you will see that as you count across, these 2 bottom categories here that are pulled out actually fit right up here where there's a little blank left. Really, the only reason that those are pulled out is the fact so that you can fit the periodic table onto one piece of paper. They go, the rows, in atomic order: hydrogen 1, helium 2, reload, lithium 3, beryllium 4, boron 5, etc., all the way through. If we drew, let's say, an energy level diagram, the number of energy levels that you have tells you which period you're in. For instance, if you were in period 4, let's say for calcium right here, element number 20, you would have had 4 energy levels. 2 in the first, 8 in the second, 8 in the third, and then 2 in the fourth. 4 energy levels because you were in period 4. Now, unlike periods, which are rows, we also have vertical columns. These columns are called groups or families. Each of these columns have similar chemical properties, which means they have the same number of valence electrons, electrons in the outermost energy level. If we take a look here then we have family 1, family 2, family 3, 4, all the way up to 12. Those are the ones in the dip here. 13 through 18. From previous studies, you already know the name of some of these families. The interesting thing about these families is the valence electrons for the representative elements. So that would be the ones in group 1 and 2, and groups 13 through 18. These elements, if I subtract the 1 in front, so if I count these as 1, 2, lose the 1 in front, 3, 4, 5, 6, 7, 8, that's the number of valence electrons you will find in their energy level diagram. So if I was to pick something like, I don't know, neon right here, you would see that neon, which is element number 10, would have 2 electrons in its first shell, 8 electrons in its second shell. It has an 8 valence electrons, 8 electrons in its outer shell because it is in group 18. Drop the 1 in front. This is true for only those elements that are not in the dip. So this is for the representative elements. Family 1, 2, 13 through 18. Now, the neat thing about the periodic table is it's got a staircase line. The staircase line is what we use to separate the metals, everything over here, from the nonmetals. Now, most of the time, nobody ever gets those wrong. Because if I start looking at the elements on each side of the staircase line, when you're looking and you're like, ooh, lead, tin, gold, silver, copper, titanium, all those sorts of things, these are all metals. We know that already. They are going to be on the left side of the periodic table. Metals all have the same properties. They are shiny. They are solid, except for mercury. They are malleable. Malleable means that if I took a mallet and I mashed onto my piece of metal, I could punch it into a sheet. So I can take a mallet, punch it into a sheet. Because I can punch it into a sheet of metal, that is malleable. Ductile means that if I heat it up, I can actually stretch it, let's say, into a wire. So metals are also ductile. Metals are good conductors of heat and electricity as well. On the right-hand side of the staircase line, these guys are all considered nonmetals. Again, most people never get this wrong because start looking at what's on that side. Oxygen, for instance, is a gas. It's certainly not a metal. We breathe it in, so this is a nonmetal. Nonmetals appear dull. They're solid, liquid, or gas. They're not malleable. So if I were to hit them with a mallet, they wouldn't smash out into a nice sheet. They would actually crumble or break up because they are brittle like sulfur, a nice yellow hard solid. I smash it with a hammer, they are going to just break apart into smaller pieces. They're not ductile, which means when I heat it up, I will not be able to stretch it into a wire. They are also poor conductors of heat and electricity. There is a third category on here, and you can see I kind of shaded them a grayish color. Those are called metalloids. We're not going to look at metalloids in this course. However, a metalloid is really, each of them is unique. They might have one property of a metal over here and a few properties of a non-metal on the other side. And then the next metalloid might have a completely different property of metals and a different property of a non-metal. They are all very unique and distinct for themselves. That is why we won't look at them in high school. So let's take a look at some of the groups. Four of these groups you already know. So you should already know walking into this class that group one are the alkali metals. Now you will notice that I did not color hydrogen as an alkali metal. Hydrogen is the bad boy of the periodic table. He tends to break all the rules. Hydrogen is the only element that's on the left-hand side that is actually a non-metal. So if hydrogen is a non-metal, he can't be classified as an alkali metal because he's not a metal. So everything in this column, whether it be lithium, sodium, potassium, rubidium, cesium, or francium, they all are soft, silver-colored metals. They have one electron in their outer shell. Their ion has a +1 charge, and all of them react violently with water and halogens. As you go down the column, they also get more reactive. So francium is going to be the most reactive. Lithium is going to be the least reactive. If I take a look, I have a picture here of sodium. So sodium would fit on here as well, right here. So sodium would have 2 electrons in the first shell, 8 electrons in the third shell, and 1 electron in its outer shell. I know it's got 1 electron in its outer shell because it's in group 1. I also know that it has 1, 2, 3 distinct energy levels because it's in period 1, 2, and 3. So little hints on the periodic table. Well, next to the alkali metals in group 2, we have something called the alkaline earth metals. These are light reactive metals, but that does not include beryllium, magnesium when we talk about the lightness. All of them form oxide coatings, or they look dull when they are exposed to oxygen. So if you've ever seen a piece of magnesium burned here, like in the picture, we have to, when we cut a piece of magnesium, clean it first. Because it's come in contact with the air, it gets like a dark gray or a black. That extra color on top, that coating on top, that is the oxide coating. So we have to take some steel wool, clean it off, get it back to its shiny metal luster. And then you have pure magnesium again. And then when you light it on fire, you're going to get to see this bright white light. Again, if we go down the column, we are looking at beryllium, magnesium, calcium, strontium, barium, and radium. These guys all have 2 electrons in the outer shell, so they have a 2+ charge. If I take a look at our example of magnesium, again, you can see we have 2 electrons in the first shell, 8 in the second, and then 2 in the third. It has 2 valence electrons in the outer shell because it is in group 2. It also has 3 energy levels because magnesium is right here in the first, second, third period. So again, pointing out the tricks of the periodic table. You also should already come into this class knowing that group 17 are halogens. Halogens are the only group on the periodic table that represents solids, liquids, and gases all in the same group. If I go down the column, you can see that we have fluorine and chlorine, gas. We have bromine, liquid. And we have iodine and acetine, solid. There are 7 electrons in the outer shell. They all have a 1- charge. And all the halogens react violently with alkali metals. However, unlike in alkali metals where we go from least reactive to most reactive when we go down our table, in the halogens, we get the most reactive as we go up the column. So we go from least reactive to most reactive being fluorine, which means on the periodic table, the most reactive element is top right-hand corner. So fluorine is my most reactive. Helium is the top right-hand corner, but as you will see in a few seconds when we look at group 18, they aren't reactive at all. So this rule doesn't take into account the noble gases. Taking a look at chlorine, chlorine would sit right here. You'll notice that chlorine is in period 1, 2, 3. I know this as well because there are 3 energy levels. You'll also notice that chlorine is in group 17. Well, because it's one of the representative elements, meaning it's not an element in this dip, take group 17, lose the 1 out in front. So think of the 7. That's how many valence electrons it's going to have in its outermost energy level. 7. The last column we're going to do for review that you have seen before is going to be group 18. Group 18 is called the noble gases. All 6 of these are gases. We are looking at helium, neon, argon, krypton, xenon, and radon. They have low reactivity. They are 100% stable. And because they are stable and they have full valence electrons, the word of the day that we call for noble gases are they are inert, meaning they will not react. They do not come with an ion form because they do not want to gain or lose electrons to get to a full energy level because they already come with a full energy level. If we take a look here, I have an example of krypton. Krypton, you can see has 1, 2, 3, 4 energy levels. Therefore, krypton will be in period 1, 2, 3, 4. Here will be krypton. Krypton will have 8 electrons in its outermost energy level. We know that because as we go up, if we drop the 1 in the representative elements, it has 8. So that puts 8 electrons in the outermost energy level. Up until now, each of these 4 groups you have already been able to name walking into this room. You have group 1, alkali metals, group 2, alkaline earth metals, group 17, halogens, and group 18 are new inert noble gases. What I would like to point out is 4 more categories that I would like you to put into your notes. This first group that we have pulled out, you will see that we call these lanthanides. These are the rare earth elements. You will also notice when you look at your periodic table why we call them the lanthanides. So take a look at either right here or up here where we pulled them out, at which element we are actually pulling them out at. Lanthanides is based on the category of where they actually got pulled from, Same with actinides. Actinides down here would be again period 7. So it actually fits into this row right here. If you watch the counting of the atomic number, you will see that they actually fit in right here. Again, they've only gotten pulled out so the periodic table can fit on one piece of paper. Other than probably plutonium or uranium, you probably don't know any of the lanthanides or the actinides. You might have heard a name, but you probably don't know anything about them. The other 2 categories that are rather critical for us are transition elements. We don't actually do anything with a transition element in high school. We usually stop when it comes to drawing Bohr diagrams or energy level diagrams right here at element number 20, which is calcium, because element 21 is going to be in the transition elements, and we're not going to do any drawings for them. So transition elements are anything in groups 13 through 12. The representative elements, you've heard me talk about quite a few times now, they're anything in group 1, 2, 13 through 18. This is the group where, if you're a representative element, I can predict without drawing their picture how many valence electrons they're going to have. Because if you're in group 2, you have 2 valence electrons in your outer shell. If you're in group 15, you will have 5 valence electrons in your outer shell. That should clear up everything we have for the periodic table. Pretty straightforward. Again, want to point out hydrogen is not an alkali metal because it's not a metal.